You're not going to want to miss this episode of the AI Show where we talk all about the latest from Azure Multivariate Anomaly Detection with my good friend Louise. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're going to talk all about the latest from Azure Multivariate Anomaly Detection with my friend Louise Hahn. Louise, how you doing, my friend?
Hi, Seth. I'm doing great. And hi, everyone in front of the screen. This is Luis, and I'm the product manager of Anomaly Detector Service. And today, I'm really happy to be here in the AI show to announce the GA of our new feature called Multivariate Anomaly Detection.
That is fantastic. So before we dive in, can you tell us what it is for those that might not know what it is?
Yeah, for sure. So a holistic overview of anomaly detector service is that it's an AI service can help you detect anomalies on your time series data. So the input is really simple. You just give your time series data, and then all the complex, all the machine learning thing is all handled by anomaly detector service, and the output will be the anomaly detection results within the response. So that's basically the thing, and I will show you a demo here of how it works. Okay,
Fantastic.
so.
Before I get to that, so let me just see if I understand. If I have data that has a timestamp on it, basically, that has
Mhm.
multiple dimensions, if something happens that's out of the ordinary, this service will basically tell me this is out of the ordinary. Am I getting that right?
Exactly the same.
Fantastic. Well, let's go to your screen here.
Perfect. So here you can see there are 5 common sensors from a car. Instead of a car, maybe another equipment or a really complex system, they will have multiple variables. And at that time, you will not have that enough time to deep dive into every single variable because there is a lot bit cost and human resource and also the time. So you have to use one model to handle all the variables in your equipment, in your system. So that is multivariate anomaly detection's magic. So here you can see we have these 5 sensors already prepared. And then what we should do is just train a model based on your historical data. After I click this button, it will take several seconds because this is an animation from the demo page. And after that, the model is trained. What you should do right now is to trigger the inference. So the inference is actually the anomaly detector service to help you detect anomalies on your model with your data, with your inference data side. So here you can see the results of all the inference results. So here you can see there are some red bands here. The white red band will show you the anomalies. So if I just click one anomalous timestamp, I can get something like this. So I can first get the severity. So this is a chart of the severity, show you how severe this anomaly is. So for example, if the severity is at a really high number than the others, then at this timestamp you have to take care because probably there will be a disaster happen right after this timestamp. And
That's amazing.
besides
So
that,
if I could
yeah.
pause, we could pause right there because I
Mhm.
this is awesome. So if you scroll up, basically what you're saying is that that first chart at the top, if you scroll up a little more, those are the sensors coming in. Those
Yeah.
5 sensors. So one is like an optical filter or whatever, a pump pressure or whatever, and you basically click that thing and it found where there might be potential problems. Am I getting this right?
Yes, yes, perfect.
Fantastic. And so the severity of the anomaly is the second chart. The third chart I didn't understand as much. Can you tell me that what that one is a little bit more?
Yeah, that's what I want to say right now. So the contributor is something called the contributor rank. So for example, when I click this timestamp, we can get a chart like this. So you can see these are exactly the 5 sensors that I showed in the inference and also the training data site. And the percentage is showing the contributor score for this anomalous timestamp. For example, at this timestamp, we can see the first sensor is optical R filtered. It is having the largest percentage in this contributor rank. So that will mean this sensor contributed the most to this anomalous timestamp. So if you don't have enough time to deep dive into all the sensors, you can just focus on the top 1 or top 2, which are the most anomalous sensors. So that will help you to do the root cause analysis.
That is really cool. So I mean, you obviously you've showed us the easy way to do it. Is there a way, for example, for me to do this, if I want to integrate it as part of some system or write my own code with it? Is there a way to do that?
Yes, for sure. Because our service is a site of APIs, so you should definitely to use the APIs or the SDK function to try to train and also to trigger the inference for your multivariate anomaly detection work. So here is the demo notebook for the multivariate API, and you can see here are some basic introduction of how we are using this multivariate model and how the process is going. So we separate all the 7 APIs into 3 parts: the training, the inference, and also the list and delete model. So you just use the training model API to trigger a train to create a model, and then you get a model status by this API, whether it is successful or it is failed or is still running. And after you get a ready model, you will trigger an inference. So here we support 2 kinds of inference. The first one is the asynchronous inference API. So with that, you can do some batching or macro batching inference. And with another inference API called the synchronous inference API, you can trigger that like a streaming or a near real time or real time inference. So these are some different options for your preference. Okay, so
This is
these are.
cool. This is
Mhm.
really cool. So basically what you did before, it just called these kinds of APIs with this nice, this is the back end if you want to make your own kind of back end as well.
Yes,
Cool.
exactly. Yeah, and I will scroll down a little bit to see the codes. So basically the prerequisites is to create an anomaly detector service in the Azure portal, which is really similar to other coding services. So you just create that and copy your key and endpoints and paste it here. And at the same time, because you will use your data to do training and use your data to do inference, and for your security, we don't store your data. So you have to create your storage account to store your data, and the upload and the preparation is really simple. So you just prepare your data in one CSV or in separate CSV files and upload to the storage account, and tada, you will get the blob URL, which is really easy to get in the storage account. And then is the coming to the prepare your data part. So you will specify your data schema and also the blob storage, the blob URL for your data, and then you will go to the key part is the training model. So within training model, we have already set everything for you. What you need to do is just download this distributed notebook and run in your local compute, and to set some training start time or training end time based on your data's preference. And then you just run this part of code, and with few minutes or with few hours, it all depends on your data size. And then you will get the model status by this piece of code. So here you can see the model is ready. Then you can go to the inference part. And the inference, as I just mentioned, we have 2 different types of inference, which is the synchronized one, which is I called batch inference here. And with that, you can trigger a batch inference with this piece of code, and you will trigger that with a result ID for that inference task. And you will get the batch inference results and also the status. So here is the final results of my batch inference. So you can see here we get whether it is an anomaly for this timestamp and the severity and also the score, which is the raw number of this severity. And we will also get more interpretation, which is like just showed for the contributor rank stuff. So this is all the things in a data frame. And also for another different type for streaming inference, it's pretty the same. So you just give the data as a JSON format, and then you will get exactly the same pattern and schema for the streaming inference detection results. So it's here. And also we have 2 other operational list models and delete model APIs. So you can list your model based on their display name and also based on their status to select whether this model you will delete or you will do some modification on that. So final is the part of the visualization. So you can see here, I just input my raw data for the 5 sensors here, and then I will draft a picture to let you know how complex this question is. It's really hard for me or for, I think, for any people
Yeah.
to check whether it is an anomaly or not. So that's why we exactly need this service. So after we apply our service onto that, we can see all the anomalies has already been marked as right. And at the same time, we'll get the score and also get the severity here in this line chart. And most important is about the contributor rank thing. So you just run the piece of code and you will get at this exact the specific timestamp how is the contributor rank looking like. So you will get something like this. And the last thing I would like to highlight here is about the change the variables, because the underlying model is the graph attention network. So we'll learn the correlation between different variables. So for example, if the sensor 1, the series 1, and the series 3, and the series 1 and the series 4 have some really big changes on their correlations, so we'll mark this as a really big anomaly. So that will have the top contributor score. So this is the table that you should look at and should take care and also take action on. So basically, that's all for the multivariate.
That's really cool. And like you literally just shoved all this cool information in my head, because when I looked at the original sample data, it just looked like fuzz. There's no way I would scroll up to the one. It literally
Yes.
looked just like fuzz. And then when you went through the model, it said, "Oh, wait a minute. I know to you, dear human Seth, it looked like fuzz, but there's some anomalies in there that maybe you should take a look at." So that is actually really, really cool. So a couple of questions. Are you finding, like, if I'm thinking about use cases for this, what should I be thinking about? Like, is it any time series data useful in this type of scenario?
So currently for this multivariate, it's better to use some really high frequency instead of just cycling, maybe minutely or hourly. That would be good, because for the multivariate, we need a lot of data to learn and to train the model. So if you have data like in monthly granularity, it may not be that good. And for monthly, that will most happening in some business metrics. But in really complex system like the car or some X-ray machine or some drilling rig, or there are some production line on the pumps. So that will be perfect thing and perfect equipment to be detecting anomaly on.
That's a great suggestion. So step number one, make sure you have a lot of data so that it can learn what the patterns are and then show you when those patterns are being violated, so to speak. The second question I have is, can we use that model to predict into the future? So let's just say I get a bunch of 5 new input sensor data on the new timestamp. I can put those in and the model can predict basically the things that are happening in the future as well. Is that right?
Currently, the forecasting is happening under the model instead of just to give you an output of the forecasting thing. So you can understand this multivariate is combining the forecasting and also the anomaly detection together at the same time.
I see. That makes a lot of sense. Well, this is amazing stuff. Where can folks go to find out more?
Yeah, actually, we have a good documentations, and we also have the GitHubs like here, so you can focus on the link that Seth will show, I think, down below the screen,
This
and
one
go
right
to
here,
the
right?
docs. Yes, perfect. Go to the docs, go to the GitHub repos, and also we have a cool Teams channel. You can join the Teams channel. The community will share with you a lot of updates of our products, and also you can feel free to discuss about our products or any machine learning thing.
Well, this has been amazing, Louise. That was a lot of information you put into our heads. This has been delightful. Thank you so much for spending some time with us.
Yeah, thank you so much for having me.
Awesome. Well, my friends, you've been learning all about the latest from Azure multivariate anomaly detection with Louise. Thank you so much for watching, and hopefully we'll see you next time. Take care.